A volume of 670 mils of gas is collected at 100 degrees Celsius at 780 millimeters mercury, and we've been given a sample mass here, and we want to figure out the molecular weight. Well, first of all, what we want to do is figure out what was we after with molecular weight. We're after grams per mole. Now we've already got grams here. Now we need to find moles. Now the way we're going to do that is we're going to use this information to find the moles, and the equation that's best suited to that is PV equals nRT, and the N is the moles, so we can do PV over RT. What we've got to watch out for though is that we make sure that all of these, the PV and the T, have the same units as the value we're using for R. So what we want to do first is probably write down our values. Now I'll start off with R, and that's going to be 0.08206 liters atmospheres per mole per Kelvin. So the -1 here just means per. It could also be written as liters atmospheres per mole per Kelvin. That works as well. You'll see it in either. You can see it in either of these forms. Alright, so the first one is we've got a pressure of 780 millimeters of mercury, but that has to be in the same units as what we've got down here for R. Now R has a unit in atmosphere, so I have to convert this to atmospheres as well. And the way I'll do that is by using the conversion factor. 1 atmosphere is equal to 760 millimeters of mercury. Now what that does is it gives me a value of 1.03 atmospheres. Now the volume here is given as 670 milliliters, but that also needs to be in liters, so we'll go ahead and we'll convert that to liters. And that's going to be 0.670 liters. The number of moles we don't know, and the temperature is given as 100 degrees Celsius, and that's we're going to have to turn into Kelvin. It's going to be 373 K. Alright, so now we can go ahead and figure out our number of moles, and that will be the pressure, which is 1.03 atmospheres, times the volume, which is 0.670 liters. That's over the R value, which is 0.08206 liters atmospheres per mole per Kelvin. And that's times the temperature, which is 373 K. Now what I want to show you here is that the atmospheres and the atmospheres will cancel, the liters and the liters will cancel, the K and the per Kelvin will cancel down here, and what we're left with is moles to the -1 that's on the bottom here. So what that's going to do is it's going to give us a figure that's in moles. Then at the end, all we have to do is we take this number of grams, divide it by the number of moles that we calculate, and that's going to give us our molecular weight.